This is Unit 5, Lesson 2, Rational Exponents. Today we're going to learn how to convert a radical to an exponent that is a fraction. The definition of a rational number is any number that can be written as a fraction. So if you are learning about rational exponents, we're talking about exponents that are fractions. To convert something to a rational exponent, I'm going to use this one down here first. If I have the cube root of x squared, I can convert that to a rational exponent. I keep the base, the x, and then these numbers will become my fraction. I'm going to take it and I'm going to kind of rotate it around so that my 2 is my numerator and my 3, my root, is the denominator. So that the cube root of x squared is the same thing as x to the 2/3 power. Okay? X to the 2/3 power is the same thing as the cube root of x squared. So knowing that, if we have something like this that has a root but does not have an exponent here, this is understood to be a 1. So that is 4 to the 1/3 power. And then anytime we're trying to simplify these type of problems, we want to get our base number as small as it can possibly be. So hopefully you understand that a 4 is the same thing as 2 squared. And so if we have 2 squared to the 1/3 power, that's the same thing as 2 to the 2/3 power, which is also, if we convert it back, the same thing as the cube root of 2 squared, which is the cube root of 4. Here, the fourth root of a would be a to the 1/4. And you will have a section in your homework tonight or in your Delta Math tonight where you're just simply converting back and forth from radical form to the form that is in the rational exponent form. Okay? Here, this would be b to the 3/5. So the root number goes on the bottom, the exponent goes on top. The exponent is your numerator, the root number is your denominator. So you will be going back and forth. If I start out with a rational exponent like x to the 5/6, that's the same thing as the 6th root of x to the 5th. And you should be able to go back and forth with these, going from radical form to rational form. That takes us to some radical expressions that we haven't been able to solve yet. So far, if we had different root numbers, we could not do anything to something like this. But now that we know how to convert radicals to rational exponents, we can now simplify things that have different root numbers. This is understood to be a 2 squared. 4 is the same thing as 2 squared. So that's the same thing as the cube root of 2 squared. 8 is the same thing as 2 cubed. So if we can get our base numbers the same, then we can simplify using rational exponents. So if I convert this to a rational exponent, that is 2 to the 2/3 times, convert this to a rational exponent, that's 2 to the 3/2. And now that my bases are the same, I've made my bases as small as possible, my rules for exponents remain constant. So we are still going to be able to use our rules for exponents that we learned in the last chapter. So here I have 2 to the 2/3 times 2 to the 3/2. I can keep the base and then add my exponents. So that would be 2 to the 2/3 plus 3/2. I can use my calculator to solve that. 2/3 plus 3/2 is 2 to the 13/6. Looking at this one, if I have the cube root of x squared times the 4th root of x, before I couldn't do that because the root numbers were different. But now I can convert them to rational exponents. This is x to the 2/3 times x to the 1/4. And now I simply add my fractions together. So I keep the base and add 2/3 plus 1/4, which is 11/12. With these types of problems, sometimes the directions will tell you to write the answer as a rational exponent, and sometimes they will say to write the answer as a radical. So I can still, even if they tell me to write the answer as a radical, I can still use this method to simplify it into a single radical and then convert it back to the 12th root of x to the 11th. So you just have to read the directions to determine how you're supposed to express your answers. If they don't specify, then it really doesn't matter. Here, the rules for dividing monomials would apply in this case. So I'm going to simply switch this to a rational exponent. That would be x to the 5/2 over, this one would be x to the 2/3, and then I'm going to subtract 5/2 minus 2/3. That would be x to the 11/6. Then I could express my answer as x to the 11/6, or if they ask me to convert that to a radical, that would be the 6th root of x to the 11th, which can be simplified to x times the 6th root of x to the 5th. Normally, I think they would ask you to leave it in that form because it's a little bit simpler than this. But you do need to understand that they are the same thing. For this one, first I would convert it to rational exponents. So that's going to be x to the 2/3 times x to the 3/4. Then I would keep my base and add the 2/3 plus the 3/4, because remember, when we multiply monomials together, we keep the base and add the exponents. You can use your calculator or Desmos to add those together, and that would give you x to the 17/12. Here I have a few more different types of examples. In this one, they're asking you to figure out what the a value is. The directions say to find a. So what we would do is, they're already as rational exponents, so we're going to keep the base and we would add the exponents together. So 1/3 plus 3/2. That would equal x to the 11/6 power. Here, again, my rules for monomials still apply. So if I have an exponent on the outside of the parentheses, I would multiply those together. So that would be x, I keep the base, and multiply these together. That would be 3 times 1 is 3, 2 times 2 is 4. So x to the 3/4. So for the answer to these, if this was in Delta Math or something where you had to fill in the blank, what I would put in the blank for this one, since the directions said to find a would be 11/6. So I would type 11/6. Here, again, they were asking me to find a, so here my a value would be 3/4. They may ask you to find a little bit differently. If you look at this problem, they have two separate numbers underneath radicals, but right here they have find a, and they give you that 2, this thing equals 2 to the a. So what they're telling us to do here is they're asking us to convert everything here to a power of 2. Well, hopefully you understand that 8 is the same thing as 2 cubed, and 16 is the same thing as 2 to the 4th. So if we're converting that to rational exponents, this one would be 2 to the 3/2, and this one would be 2 to the 4/3. And then if we want to figure out what a is, we would keep the 2 and we would add the exponents together. So 3/2 plus 4/3 is equal to 17/6. So a would equal 17/6 in that case. Here is something a little bit different, and I'm just trying to show you different examples of different ways they can express rational exponents. In this one, that rational exponent, if that root number is a 3 and the power outside is understood to be a 1, wouldn't the stuff inside be taken to the power of 1/3? And we learned that when we were doing powers of monomials, that 1/3 could go and multiply by all the powers on the inside. So that would be 1 to the 1/3 over m to the 7/3 times m to the 8/3. 1 to the 1/3 is just 1. And m to the 7/3 times m to the 8/3, well, we would add those together. That would be m to the 15/3. And then they might give you choices. Which of these is the same as m to the 15/3, or 1 over m to the 15/3? Well, if you think about that, isn't that the same thing as 1 over m to the 5th? So which one of these is considered the same as 1 over m to the 5th? Hopefully you're saying that's the same thing as B. Now, if the directions just said to simplify, hopefully you remember we are not really supposed to have a negative exponent in our answer. So if I ended up with a negative exponent, I would prefer to write it this way. But if they give you multiple choice questions, and they just want to know which one is equivalent to what you got, well, then the only one here that is equivalent to what we got is the B, which is m to the negative 5th. For this one, 3x to the negative 2/3, we are, again, not allowed to have negative exponents in our answer. So if I were to write that one, I would say that that is 3 over x to the 2/3. And then, technically, since radicals are not allowed to be in the denominator because we have to rationalize our denominators, wouldn't that be the same thing as 3 over the cube root of x squared? And aren't we not allowed to have a radical in the denominator? If that's the case, we're also not allowed to have fraction exponents in the denominator. So how could I get rid of that fraction exponent? Well, if I make that fraction exponent a whole number, then I can get rid of the fraction exponent on the denominator. Well, ask yourself, what can you add to 2/3 that would make that a whole number? Well, 2/3 plus 1/3 is 1. So if I multiply the top and the bottom by x to the 1/3, I can get rid of the fraction exponent. So on top, I would have 3x to the 1/3. On the bottom, I would have x to the 1st. And I would leave it like that because I'm not allowed to have fraction exponents or radicals on the denominator. Now, if you think back to when we did that in chapter 1, or really earlier in this chapter when we did it in lesson 1, wouldn't that be the same thing as, let's see, we have 2 x's. How many more x's do we need to get rid of the radical? Well, we need 1 more. So I could multiply by the cube root of 1 more x. And if I simplify that, isn't that going to be 3 times the cube root of x over x? And if you think about that, isn't that equivalent to what we have here? Technically, they are the same thing. How you would represent your answer depends on what the directions ask you to do. The main thing here, though, is that you need to understand 3x to the 1/3 over x is exactly the same thing, or equivalent to 3 times the cube root of x over x. Here we have 1 over 2x to the negative 3/2. Since this entire denominator is to the negative power, and we're not allowed to have negative exponents in our answers, how do we get rid of the negative exponent? Well, to get rid of a negative exponent on the bottom, we change it to a positive and move it to the top. So I am allowed to take this 2x, move it to the top as a positive 3/2. And then that's the same thing as 2 to the 3/2 times x to the 3/2. That means exactly the same thing. I would guess, though, that they want you to express that answer probably as a radical. So they probably want you to express that as the square root of 2x cubed, which is the square root of 8x cubed. And then you could simplify that. We can bring a 2 out, we can bring an x out, and that's the same thing as a 2x inside, so that's 2x times the square root of 2x. So really, all of those different things are equivalent to each other. The 2x to the 3 halves is equivalent to the 2x times the square root of 2x, and that's equivalent to the square root of 8x cubed. This, however, is not simplified until you write it this way, and I would always write it in simplified radical form if I leave my answer as a radical. For this one, I'm giving you choices A, B, C, D of what the right answer is, or which of these is equivalent to your answer here. And sometimes they may do it this way just to see if you know what two equivalent things are. They may not want answers expressed necessarily this way because they're not necessarily in the most simplified form, but it's important for you to understand when two things are equivalent to each other. So if you look at this, since the 1/3 is on the outside, I'm allowed to multiply or distribute that 1/3 to all the powers on the inside. So that is the same thing as x to the negative 8/3 times x to the positive 4/3. And then my negative 8/3, since it's a negative, could go to the bottom. So that's the same thing as x to the 4/3 over x to the 8/3. And then I'm going to subtract my fractions from each other. Now, I know that 8/3 is larger than 4/3. So I'm going to subtract 8/3 minus 4/3, and I'm going to keep the leftovers where the number was the biggest. 8/3 is larger than 4/3, so I'm going to keep my leftover 4/3 on the bottom. I'll have a 1 on the top. That is the same thing as 1 over x to the 4/3. It's also the same thing as 1 over the cube root of x to the 4th. Now, how do I need to express this answer? Well, that's going to depend on the choices that they have given you, okay? Now, normally we're not allowed to leave fraction exponents or radicals on the denominator, but if they've left your choices that way, you might be allowed to leave them that way. So this one, 1 over the cube root of x to the 4th, well, the 4 and the 3 are backwards here, so it's not that one. Here, we have the 1 has not been accounted for, so it can't be B. Here, again, we haven't accounted for the 1. It can't be that one. And then with this one, 1 over x times the cube root of x, well, if you look at this, couldn't that be simplified? Couldn't we bring an x out? That's not necessarily the best way to simplify it. I would get rid of the radical on the bottom, but your directions were to just find which one matches, which one is equivalent. The only one here that is equivalent would be D. This last one is very similar in that we have to figure out which of these is equivalent to what we've been given. So I would just go through and try to work out what I can and then try to get it to match one of the choices that they've given me. So here, the x to the negative 4 to the 3 halves power, or the 3/12 power, I'm going to multiply 3/12 by each of the powers. So 4 times 3/12, or negative 4 times 3/12, that would be negative 12 over 12, or negative 1. And then the negative 2, x to the negative 2, negative 2 times 3/12 would be negative 6/12, which is the same thing as negative 1/2. Then, if I have negative exponents, I need to change them to positives and put them to the opposite spot. So if it's a negative in the numerator, I change it to a positive and put it in the denominator. If it's a negative exponent in the denominator, I change it to a positive and put it as a positive exponent in the numerator. So here, x to the negative 1 goes to the bottom as x to the first. And here, x to the negative 1/2 goes to the top as x to the positive 1/2. Now, look at how the answers have been expressed. They've expressed the answers as radicals, so we need to convert back. Well, x to the 1/2 is the square root of x. X to the first is just x. I don't see any that match this, So I need to do a little bit more simplification. Well, if you think about this, 1 is larger than 1/2. Since those two are over top of each other, couldn't I do 1 minus 1/2, which I know is 1/2. So 1 minus 1/2 is 1/2. It was bigger on the bottom, so that's where my remainders are going to go. So that's the same thing as x to the 1/2 underneath 1. I still haven't matched it yet, but if I convert this to a radical, that's 1 over the square root of x. And I see that that is answer choice B. So which one you pick and how you simplify your answer is going to depend on how they have presented your choices.